Welcome back to Ballroom 2. Our next talk is by Meg Ashby. She'll be presenting on balancing security and costs in AWS VPC interface endpoints. I'd like to thank our sponsor, Prisma Cloud. Prisma Cloud is the industry's most comprehensive cloud-native application protection platform with the broadest security and compliance coverage for applications, data, and the entire cloud-native technology stack throughout the development lifecycle across hybrid and multi-cloud environments. Our integrated approach enables security operations and DevOps teams to stay agile, collaborate effectively, and accelerate secure cloud-native application development. Please welcome Meg.
Awesome. So great to be here with you all this morning. Like they said, in this room, we're discussing balancing security and costs with AWS interface VPC endpoints. So if you actually thought you wanted to attend a talk on cloud service provider partnership portals, the boarding doors have now closed and you're stuck here with me. But with that, we'll go ahead and get started. So we'll start with the boring stuff, and that's me. I'm Meg. I'm a senior cloud security engineer at a FinTech based in New York City. I've been doing cloud security and security adjacent work for about 3.5 years. And this is my first time speaking. I say those last 2 points as a slight plea to please be nice. And if you're someone who really likes GitHub and Terraform, the architecture that I'm using throughout our demo is available if you want to play with it and duplicate it at home. So a little bit of our agenda. We're going to talk about the centralized VPC endpoint architecture. We're going to talk about different ways that we can interject security into that. We're going to do some demos around policies, and then we'll finish it up with Q&A and questions. So for your convenience, I've gone ahead and copy and pasted AWS's reference architecture for centralized VPC endpoints. In short, if you're not familiar, what happens here is that instead of having our VPC endpoints in line with our spoke or workload VPCs, you can see those up here in pink, what you do is centrally host, essentially, your VPC endpoints in a designated VPC, and then use Route 53 private hosted zones to share those endpoints. And you might be wondering, if we have fewer VPC endpoints, and that means fewer VPC endpoint policies, and that means fewer VPC endpoint policies, less granular security. So why am I here talking to you at a cloud security conference about less security? And the answer is simple. Because when you don't centralize your VPC endpoints, AWS makes a lot of money. VPC endpoints are often touted, and they have great benefits in terms of implementing data perimeters, keeping your traffic private to your network and AWS's network, and they are also characterized by having a lower cost of processing traffic compared to something like a NAT gateway. However, when you actually start using these VPC endpoints, you'll find that they also have an added feature for AWS, being that they have a running cost per hour. So when you're looking at it practically, in order to make the cost-benefit neutral, you have to be sending a lot of traffic through those VPC endpoints to make up for the running cost per hour. And so essentially, the centralized VPC endpoint architecture is a cost savings mechanism. So with that, we're going to touch quickly on the different interjection points where you can put security into this design. So there's 4 main places that I'm going to touch briefly on. So the first is at the Route 53 Private Hosted Zone Association. Secondly, on the security group of the interface on your designated centralized VPC endpoints. Third, on the resources access through the VPC endpoint. And then what we'll be talking about today mostly is on the VPC endpoint policy. The same things shown just in a diagram. Here, the Private Hosted Zone Association, if you don't want a given workload VPC to use your centralized VPC endpoint, just don't associate. The private hosted zone and the DNS won't use the VPC endpoint. The con here is that it's only on your VPC layer, So it's pretty widespread, and you don't have any control over IAM actions, principals, resources, anything like that. Similarly, on the security group of the interface itself, you could do your normal security group rules. So if you wanted to get a little fancier with subnetting, allow listing, deny listing your IP addresses, you could do that here. But again, no control over the IAM actions. And then you are also potentially going to run into the risk of everyone's favorite resource quota, which is how many security group rules you can have attached per security group with Elastic Network Interface multiplied, blah, blah. No one cares. And then the third place that we're not talking about today is on the resources themselves. So depending on how you deploy your infrastructure, whether that's CloudFormation, Terraform, or good old ClickOps, you might find that it is management nightmare to put these sorts of controls on all of the resources accessed through VPC endpoints. And so for that reason, we're going to be speaking today about the policy on the VPC endpoint itself. So for some people, they like to kind of kick all the problems at the end. I said earlier, I'm from New York. I like to be upfront about just about everything. So I'm going to be upfront about what kind of the potential limitations, or what I call the hidden dragons, are at the front of this. So if you're familiar with building data perimeters, you're probably quite familiar with the condition key source VPC and VPC source IP. However, those are only applicable for traffic that has already passed through a VPC endpoint, so we can't use those condition keys on a VPC endpoint policy itself. We do have related condition keys that are limited to requests that come from EC2 IAM role credentials, i.e. instance profiles. So what that means is we can use these condition keys to limit access from your very vanilla EC2s and things like EKS node roles, but other sorts of compute or identities such as pod identities, IRSA, if you're an EKS, Lambda, ECS tasks themselves would not fall into these condition keys. And then just more generally, you have a limit of how many endpoints you can have per VPC. There's a limit on the number of characters, and then not every AWS interface or private link service actually supports VPC endpoint policies. If you have questions or qualms with that, take it up with the AWS folks, not me. I don't like it either. So with that, we're going to just go ahead and prep for the demos. So just so you all are aware of what VPCs and what our architecture looks like I said now at least twice, I'm from New York. And so as someone who's from New York, I understand that New York has all of the things that people from New Jersey and Connecticut want to come in and use. So VPC New York is going to host our VPC endpoints. And then we have our VPCs for New Jersey and Connecticut that are going to be our spoke VPCs, one connected via peering and one via transit gateway, just for quasi coverage, but it's a pretty simple architecture. So with that, we're going to go ahead and get started. I am going to fix the resolution very speedily. So here we go. We're going to make it faster. And make it nice and speedy. So the first condition key we're looking at here is we are denying requests that come from a very specific VPC. And so again, we're using that EC2 instance source VPC condition key, and then we're going to allow everything else. So this VPC that we are denying is Connecticut, of course. Like, why do they need to come and use New York City's things? Like, don't you have your own? So if we're coming from New Jersey, though, for this point, we said New Jersey, it's okay. Like, there's reciprocal tax laws, like, we'll let it slide for now. So what we'll see is the connections from New Jersey are able to access SQS, which is our demo VPC endpoint here, while we'll see that from VPC Connecticut, we will see that they are not able to access the centralized VPC endpoint because we've explicitly told them we are not allowing them to. So the second the second policy we're going to be looking at adds another layer of complexity. So the first statement is that the private IP must come from these CIDR ranges. And then the second condition is the one we've just covered, which is the source VPC ID. So if we look specifically at what are these CIDR blocks, you'll see very conveniently they are all of our private subnets. So essentially, when we look at this policy together, what we're saying is that we are going to allow connections from any of our VPCs as long as they come from private subnets. It is really important to note that you never want to have the source private IPv4 condition key by itself, obviously because you know that your CIDR ranges are not exclusive to you. So it's very important that if you do want to do allow listing or deny listing based off of the CIDRs, that you also include the VPCs as well. So from a private subnet, you can see everything's all hunky-dory, looks good. But then if we go and use an instance that's in a public subnet, we'll see again that we have an access denied here. So the last condition, I'm going to go ahead and pause it if my screen will allow me to do so, just so we can look at it a little bit closer. So at the beginning of the talk, I mentioned, right, that we have sleeping dragons. And one of the main issues, right, is that we can't use the VPC source condition keys because they're not applicable here. I said we do have those similar condition keys for EC2 instance role-based connections, but we are in modern architectures now. EKS, ECS, Lambda, serverless things like SageMaker, Airflow are very prevalent, right? And so those relying only on the EC2-based condition keys is going to have a decent amount of gaps in your environment. So what I'm trying to explain here is that we can, almost quasi-hack it together and try and catch those other sorts of compute or sources where the connections initiate. So you'll be quite familiar with the EC2 instance source VPC. Now we say Connecticut is fine. It's like National Connecticut Day or something. So we'll let Connecticut through. And then the second condition down here is we're going to say that we are going to use a tagging mechanism basically to do the allow listing pattern in other types of connections that are not based off of EC2 instance credentials. So here we go. We'll go ahead and verify that now we're going to allow the connections from VPC Connecticut, and everything looks good. And again, that's because we're still in that first condition that we're explicitly allowing the EC2 connections from the Connecticut VPC. But now diving deeper into the second condition, this is basically how we're trying to address, right, those non-EC2 credentials. So what I've chosen to do here, just as an example, is I've used a tagging mechanism on the principal itself, although you can use any sort of generic tagging if your organization prefers a different one. So here we have a VPC Connecticut Lambda. That's, again, in VPC Connecticut. But that's actually not what's most important here. What's most important is that it has this VPC ID tag, and so does the role that the Lambda is going to use. We're just doing the same logic that we were doing before with listing SQSQs. And what we'll see is that it's successful because the tagging mechanism does explicitly allow that connection from this principal. What we can do, though, because it has the principal tag for VPC ID, and then we've added a secondary condition that's specific to assumed roles. So in case someone was really trying to YOLO their life, they can't use like an IAM user that has principal tag VPC ID. But you might be saying, well, Meg, this is really hacky. Like, you can totally get around that, and you know you're all smart people. So what we are seeing here is that, yeah, if you tag an EC2 instance, right, you just tag it with the Connecticut VPC. I'm a New Jerseyan, masquerading now as a Connecticutan. Can't that mean that I can get access? And in the current state, yes, you totally could. So here we see EC2 New Jersey is able to access, even though we're only trying to allow list from EC2 that are in the Connecticut VPC. So what we can do is add a secondary condition to the policy. And so if you can see quite towards the bottom, that's all the same. This is all the same, but we've added another condition that the string for the AWS user ID does not match the pattern coming from an EC2 instance. So what this is basically just saying is that for that first block, right, that we're explicitly allow listing from VPC Connecticut EC2-based credentials, that's how we're allowing from Connecticut. And what this is saying is that kind of for our hack or our fallback solution, we don't want other EC2-based credentials to be able to just get around the allow list or the deny list by just tagging themselves to masquerade as they're coming from a separate VPC. Oh, don't play again. So with that, wanted to go over just a few summary things. So I hope what I'm trying to get across is that, right, there's no perfect solution when we're trying to balance both cost and security. But just because your organization has chosen in some circumstances to sway more in the cost-favorable side of things, it doesn't mean that you have to completely give up your security, especially when we're looking at this model. And you also don't have to choose one way or the other and just go with that exclusively. If you have sensitive workloads that you really want those finer granular controls on, very specifically where those connections are coming from, maybe you don't centralize those VPC endpoints for those workloads. Maybe you have less sensitive workloads that for you, all it really matters is that I can enforce my data perimeter controls, which rely very heavily on traffic going through any VPC endpoint, and that's more important to you, and you're willing to take some cost benefits in order to relax your controls here. I hope maybe you've learned something new, that you do actually have some controls, though, very firmly on EC2 instance-based credentials and using the source VPC in source private IPv4 for CIDR block level controls. And I've shown you a way that you can do tagging to help manage these sorts of things with non-EC2-based credentials. But again, if you have other tagging mechanisms, there are many ways you can do this. The global condition keys that apply anywhere for VPC endpoints are obviously going to be applicable here. So with that, if you have questions about resources or the specific conditions that we've used, these slides will be public. And then for that, everyone, questions, comments, concerns?
First of all, thanks for the presentation. It's quite a creative and interesting way to make it happen. But I'm just wondering, how would you control because the tagging of the Lambda function is not really a network control, how would you prevent the developers to just changing the tag, or maybe just forgot to change the tag when they move the Lambda function to another VPC?
Is this still on? Yeah. So I think there's a few ways to do it if I'm being realistic, right? First of all, acknowledging that that is a very valid concern, right? Tagging is a loose control pretty much anywhere that it's implemented. So in terms of initial implementation, if you're using something like IAC in whatever mechanism you're doing, the Terraform that I have shown here, sources it directly off of the VPC that the Lambda has been deployed into. if you wanted to be a little bit more firm with the controls, right, you could use certain things like automation and watching for changes in resources. And then you can also, if you wanted to get really creative on your tagging policies, I personally wouldn't necessarily suggest doing that, like on the account level. But yeah, so I would suggest doing more automation around like resource state change, that sort of thing.
Any other questions in the room? One more.
I'd love to ask a little bit about like what detections and monitoring you might want to wrap around this. Like it looks like we've done a lot here to do like preventive controls, prevent things from accessing, but I'm wondering if you look at errors or CloudWatch metrics or utilization just to figure out like what different VPCs are doing. In particular, because you're a New York person, I'll just ask like, could we implement some sort of congestion charge on a per VPC basis?
I mean, I feel like you just hit at a heartstring. If anyone's not from New York and you heard that our mayor had or governor had last minute shot down congestion pricing, RIP to funding the MTA. But yeah, so this is actually kind of an interesting question because it's actually not so easy, right? So VPC endpoints themselves are not a data plane component, so they don't have like logs for themselves. You could use like VPC flow logs if you really care to look into elastic network interfaces and do that sort of parsing. So for us, mostly it's because we do centralize the VPC endpoints, what we end up looking at is making sure, again, a balance on the resources that are particularly sensitive, checking that those have the source traffic is originating from the VPC itself. And then our secondary concern is making sure that we have traffic that is using the VPC endpoints. If you are an organization that is still keeping your NAT gateways in your workload VPCs, right, there's no guarantee that maybe you've completely set up the infrastructure that the spoke VPC can use the VPC endpoint. So for that, we use, personally, we use AWS Network Firewall because that is helping us with our egress monitoring, which gives us the add-on benefit that we can check if something is not using VPC endpoints.
Any last questions in the room? Great. One last round of applause for Meg.